Yesterday, we discussed about the scales, nominal, ordinal, interval, and ratio. That's how we basically measure our variables. Whatever the variables we are deciding, whether they are qualitative variables or they are quantitative variables, we actually measure them by giving them one some metric, right? Which could be nominal, ordinal, interval, and ratio. Now, whenever we make a questionnaire, please understand that we normally make it on either on interval scale or on ratio scale. Why do we do that? Because this is the highest level of measurement. It is always possible to convert ratio scale to interval or interval scale to ordinal. However, it is not possible to convert ordinal scale into interval or ratio. And on ratio scale, we've understood that we can apply all kinds of arithmetic operations, let it be division, plus, minus, multiplication, whatever. All these tools are available and everything can be applied. And we can apply higher order analysis, for example, regression, structural equation modeling. All these techniques can also be applied. Okay, that's the only reason why we normally take the scale always on the ratio or the interval scale. Now, what happens is somebody asked me yesterday how to develop the questionnaire. Let me just tell you what happens when we do a questionnaire. What you can do is you simply make, let me just take you an Excel before explaining this. And let me take you to, so I have taken these two papers, explain you how we basically develop the questionnaire. Look at the, I hope my screen is visible. Now, if you look at this topic, customer engagement and advertising effectiveness, a moderated mediating analysis. Suppose now you want to, you also are working on customer engagement or advertising effectiveness. So what you will do is you will go to any of the databases and you will draw a paper either on the customer engagement or advertising effectiveness. It need not be that you need to have both the scales in one paper only. So you assemble or you arrange your literature review for one folder of customer engagement and another of advertising effectiveness. And then you see what kind of scales are available. Now, how do you get the scale and from where do you get the scale when you look at the paper? So if this is a paper, you'll directly go to the, first you should look at the model, if the model is there, right? And if you look here, I'll show you the, so this is the model which author has taken. It's a simple mediation, right? This model has been taken by the author. Now, if you look at this paper, you directly go to the measures section, which is present in the RM, research methodology section, right? So we'll go to the research methodology section and there you will look at the development of scale items. Either it would be given in the research methodology section as measures, or it would be given as the development of the scale items as it is given in this paper. So you look at this, a meticulous analysis is needed for scale development as it serves as a foundation over which valid relations among the variables are established. Therefore, items have been adopted carefully. Now, please pay attention here. There are two things which I told you yesterday. One is called adopted, another is called adapted, right? So when do you call it adopted and when do you call it this adopted? When the items are taken as it is from the previous literature, then you call it as an adopted scale. And when you make few changes to it, then it is known as adapted. So the author is saying the items have been adopted carefully. That means as it is, the items have been picked from the previous literature after incorporating a few modifications so as to fit into the framework of the present study, right? So what has, similarly, the scale of informativeness included 3 items. See, the scale of informativeness is given here. Similarly, The credibility has been measured using three items: one item from the scale and four items from Wells, Levitt, and this to measure personal relevance. Attitude towards YT advertisement has been further assessed based on three items from Wang and Sun 2010 and two items from McKinsey and Lutz. Now, what you need to do is one is that you will go to whatever the items this author has taken logically. Otherwise, you will also go to the original scale. Original scale matlab, जैसे the scale of informativeness includes three items adapted from Duke. So what you will do is first you will see ki what kind of items have been adopted by this particular author. So the author has already given the scale items along with the sources are shown in table 2. So you will directly go to table 2 and you will find YouTube advertising is entertaining, YouTube advertising is pleasing, it is enjoyable. So entertainment is a construct. These are the scale items and ENT1, ENT2, ENT3 and the source. Now this source, if you want to take, here it is given Duke of. Okay? So here it is. Similarly, now if you want to now analyze this paper, what you can do is you can just pick Control C and we will advertising value and advertising on the web. So you go on this paper, see if the paper is available as full text or if not available, just try to arrange this paper and check this paper, how the scale has been studied and how the items have been studied. Similarly, you will go for the other items as well. Now, what you will have to do, let me show you in another paper also. Generation C with multiplier, online games, key gratifications and stimuli. So here also we'll go to the RM section straight away. See, this is the model where it is shown that perceived enjoyment leads to attitude. Social interactions achievement leads to attitude. Further, it leads to playing intentions and these two also leads to playing intention. So first you look at the model, whether it is talking of your variables or whether it is not talking of your variables, and hypotheses are also given. Then you check the RM section. Here is the methodology section, sample and data collection. Now, and here measures. Measures means how the items have been taken, right? So when you go here again, the questionnaire was examined by the game developers, designers in three marking tools. Professors, some changes to the wordings were incorporated based on the collective. The questionnaire contained three sections. Now your questionnaire should contain 3, 4, 5 sections depending upon how you're going to make it. The first section contains two already mentioning screening questions. The second comprised of demographic. Third section, see, look at the, is given the structure also. So the first section, basically talks about the screening questions. Now, what are these screening questions? What happens is, at times, suppose if you are looking at the factors that leads to technology adoption, right? So you cannot talk to somebody or you cannot collect the data from somebody who is basically has not adopted the technology. So what would be your screening question? What kind of technologies you have adopted, right? How long you have been using this technology. So this will help you in filtering these things, right? Suppose if you are looking at the challenges in adopting technology, then it will not matter that whether you're going to take factors and the challenges, right? So factors and challenges, when you're talking of both the things, which helps you in adoption and what are the challenges you are facing. So the people who have not adopted will give you the challenges and the people who have adopted will give you the factors. So then you can have the data from everybody, right? However, now it depends on your objectives that are you trying to get the data from those particular set of people? Suppose if you are doing some study on women, so then obviously you will collect the data from women. So your first screening question would be gender, right? Then suppose if you're doing a study on investment behavior of women, right? So that woman, whatever woman you are choosing from in whatever area you're choosing, that person should be investing. So what is going to be your first section in this case? In this case, your first section would be, where do you invest? You will give some options: mutual funds, equity, ETF, gold bonds, whatever, wherever, or invest property or whatever, right? Real estate and things like that. How much money do you invest, right? Is your family involved when you take an investment decision? So some screening questions will help you in analyzing those things. Right? So this is going to be your first section in case if it is required. If it is a general product or something where everybody can participate, then you might have some screening questions, you might not have. So it depends what kind of information you're looking at. So that becomes your section 1. Section 2 may talk about the demographic factors, or demographics may come towards the end of the questionnaire also. These days, people normally collect the demographics towards the end. So first section becomes your screening section. Second section has, here it is like given. So I will suggest the second section can be the last section also. However, there is no compulsion that you cannot consider the demographics in the second section. There is no hard and fast rule. It is just how you want to take the data. Third section comprise items pertaining to the key study constructs. Now, these key study constructs will be your variables, whatever variables you are studying. So whenever you make a questionnaire, first, these days, you must have heard of the ethical concerns these days, right? So whenever you send your paper to any of the journals, they tell you that have you taken approvals from the ethic committee or not? So these days, universities are also setting these ethical committees in their universities. So in case if your subjects are something which, and a subject on which you are actually doing research is very, very sensitive. For example, if you're working with um, some acid attack victims, or maybe if you're working with somebody who is suffering from any disease, or maybe if somebody, uh, parents, adopted parents, or maybe the parents of the children who have got autism. So the subjects are very, very sensitive in this. So you really need to have some approvals from the ethical committee, and then you should also take them in confidence that your data will only be used for this academic purpose and will not go out and things like that. So that approval is necessary, and you really need to write the 2, 3 lines in the beginning that data will be kept confidential, just to obtain their confidence and things, right? Then you make your section 1 where you obtain the screening questions and you get the screen answers to the screening questions. Second could be the demographics. Then third, you talk about the whatever the constructs you are considering. So for example, here, if you consider, here is the perceived enjoyment is one construct, right? So perceived enjoyment is one. Social interaction was assessed by 4 items taken from C. Now, look here. It is not necessary that you take items from just one author or from just one paper. You can also mix and match a few items from one author and few items from the other author. Reason being, because what happens is you really need to look at the objectives which you have framed. So whether with those items, are you able to achieve answers to those objectives or not, right? If you think that your one questionnaire or one scale, whatever you have considered, is good enough, then maybe you can go ahead with it. But you can always combine 1, 2, 3, 4, and you may, if you are adapting, and if you're not adopting, and if you're adapting, you can always um, make a change. You can always add few and you can delete also few, right? So achievement was measured based on 4 items of, again, see, again, 2 scales have been taken. Subjective norms were assessed using 3 items from only one. Perceived behavioral control was measured by adapting 3 items from this, and we adapted it. Now the point is, how do you basically collate everything, right? So what do you do? I'll suggest you one thing, how you can do that. So I'll just take you to the Excel. I'll take your questions after a few minutes, please. Huh? Suppose I am making a scale of perceived usefulness. right? So this is my construct. So you write here construct. Then you write here authors, reference paper, and number of items and items, right? Suppose author is ABC, paper is whatever impact of AI on PU or attitude, whatever, any paper. Number of items means आपके statements, how many statements you have. It could be 4, it could be 5. Items here means the statements. So you mention all the statements here, right? Your statement could be here, could be your statement 1, statement 2, statement 3, and statement 4, right? So this is finished. You have another author, DEF. Write everything. Statement 1, statement 2, statement 3, statement 4, right? Then you have, maybe you can have one more if you want, XYZ, and talk about it. And again, 1, 2, 3, 4, whatever statements you have. So what happens eventually, you've got these set of 9 or 10 statements in one sheet, right? So maybe here you can name the sheet as PU. If you want, you can have another sheet with the name of attitude so that there is no confusion. And you can make similar sheet, or maybe you can have here also, up to you, right? So whatever you're making. So now you have these 9, 10, 11, whatever statements you have. Now you see what kind of statements are these, and then you revise revised items. Now you will revise them based on your context. So whatever you choose, suppose you chose this one, or this one, whatever. So you highlight them so that you know that what changes are you going to make. Just give me 2 minutes. I'm answering your questions, please. Right? Suppose we chose these 5, right? So whatever the revised items you have considered, and finally, final scale आपने किसका लिया है? So यहाँ से आपने लिया है. So this becomes your one author, DEF and XYZ. If तीनों हैं तो आपका scale हो गया adapted from whatever authors, A, B, C, D, E, F, X, Y, Z, and whatever the year it is. So this is how you should maintain your sheet whenever you are making your questionnaire, right? I hope it is clear now. Let me just look at a few questions in the chat box. Yes, you can keep the sentence as it is. When you're keeping the sentence as it is, that means the questionnaire is adopted. But you will have to change the context, because if it is in the same context, then it is fine. In case if you want to change the context, you have to change the context. For example, if you're adopting the items exactly from the existing scale with slight change, like changing the sector, then also we will find the CFA and EFA of the scale. Then you will only go for CFA. If you are completely adapting the scale, no change in the language, nothing in the language, anything, then you will go for CFA directly. However, if you're making a change in the context or maybe some language changes or whatever, then you will have to run first EFA and then CFA. 2 items taken from one paper and 2 items taken from other paper, will it come under adaptive? It will be yes, adapted, because you're changing the scale. You have not completely adopted. You have changed the scale to measure your construct. You know, mix and match. You've done a mix match, right? Is this clear? Can we use the same items also along with the scale? Yes, you can use the same also, Sushmita. We'll talk about the ranking of products also. All right. Okay. So I hope it is clear now how you have to build on the. Yes, we can have both adopted as well as adapted. So if you suppose if there are multiple constructs, 5 or scale means the questionnaire. Yes, scale means the questionnaire. If you have multiple constructs, construct A, construct B, construct C, you can have adapted for one and you can have adopted for another. You can also have, right?
Ma'am,
Yes,
excuse me, ma'am. If is it necessary to have items from previous literature? Because if we want to introduce any new item, can we not do that?
New item or a new scale?
New statement.
See, you can, ideally, it should be from the previous literature. However, if there is just one statement which you think can be taken, you can add that statement to the scale. However, if you are not taking anything from the previous literature, and you think that the things have changed and that construct cannot be defined in the way as it has been defined previously, so then it is a case of a scale development. So you cannot, unless and until that scale has not been used or validated, it cannot be used. I mean, the items cannot be used. So you have to first validate or build the scale, and then you can use it. But one or two items, if you're adding based on your objectives, then it doesn't need any scale development, right? But it requires EF.
Excuse me, ma'am.
Yes.
Ma'am, I want to ask, suppose first I want to quote the example. Suppose I want to study product quality and customer loyalty. So there is product quality, there is another scale for the product quality and customer loyalty के लिए अलग scale है. तो इन
हम्म।
दोनों को जब merge करके, क्योंकि quality अच्छी है, that's why कुछ उसका item है, कुछ उसका item है, दोनों जब merge होंगे तो इस तरह का scale कैसे बनेगा या क्या कहेंगे उसे?
नहीं तो दो कंस्ट्रक्ट, आपके दोनों कंस्ट्रक्ट सेपरेट है ना,
हाँ.
तो फिर वो अलग अलग बनेंगे, स्केल दोनों का अलग बनेगा।
इफ द कंडीशन कि अगर ये चीज फीचर है उसमें तो मेरा सेटिस्फेक्शन बढ़ता है, अगर ये फीचर है तो मेरा क्वालिटी का ये फीचर है तो मेरा लॉयल्टी बढ़ती है। लॉयल्टी के देयर आर 5 आइटम्स एंड यहाँ पे क्वालिटी के भी 4 और 5 अलग अलग आइटम्स हैं डिफरेंट स्केल्स पे।
हाँ, so that is simple ना, you're saying that if there is a product, quality leads to satisfaction, right? This or loyalty, whatever,
लॉयल्टी, हाँ।
right? आप यही तो बोल रहे हो, correct?
यस, यस,
So you will have a one scale, separate scale for this, and you will have a separate scale for this. So
यस,
in your questionnaire, you will have few items for product quality, which will measure product quality,
यस,
and you will have few items for loyalty. That's it.
यस,
Bas,
यस मैम।
right?
ओके, तो ये इनको साथ में नहीं ले सकते क्योंकि मेरा प्रोडक्ट
साथ में
क्वालिटेटिव है,
कैसे
दैट्स
लोगे? दो अलग वेरिएबल्स है ना, साथ में कैसे लोगे आप? यू व्हेन यू विल रन द ईएफए, देन ओनली
ओके।
यू विल, साथ में कैसे? व्हेन दे दीज आर टू डिफरेंट कंस्ट्रक्ट्स ना, ऑल टुगेदर you cannot say
ओके,
that product quality is equal to satisfaction. You're saying that product quality leads to satisfaction, so these are two
यस
different
मैम,
constructs,
यस मैम।
right? So you will run it in the EFA and then see which variable, which item. There is a possibility that if your item clarity is not there, or if you are making some double barrel questions which a reader is not able to understand, so some of the items from product quality may fall into this. For that
ओके,
purpose, we need to have EFA run, so that we will understand in just few minutes from now.
ओके मैम, थैंक यू।
Yeah. Any other doubt?
Yes, ma'am. I'm having some doubt.
Yeah.
So, good evening, ma'am. Suppose I'm taking adapted questionnaire. So can we go for the EFA, right? For the adapted.
Yeah, yeah. When you are taking an adapted, you have to run EFA. In case of adoption, as Prabhakar is asking, then you will directly go to CF,
Okay, directly CFA. Okay, fine. Okay, thank you, ma'am.
right? Okay. So let's first understand what is a factor. I hope everybody is clear with the factor now. If all this, Susmita, if all the items are new, will it be called as exploratory? Because see, it is a case of an item generation. When you're saying that all the items you are introducing for the first time, then that means you have explored the items from a qualitative study. So when you are exploring the items from a qualitative study, then it is a case of a scale development, right? All right. Okay, let's understand first now.
Ma'am,
Yes.
ma'am, I want to ask related to the reflective and formative that we had discussed yesterday.
Hmm.
How we decide that we should go for the formative and reflective in case when we are preparing for the questionnaire or the items preparation?
See, usually you will find that all lower order constructs are reflective in nature. That is actually a different discussion altogether. However, I'll just give you 1 minute on this. Reflective, all lower order constructs are reflective in nature. And if you go for some higher order construct, you will, let's say, for example, service quality scale. So when you read about the service quality scale, it is a reflective scale. So you will read in the literature and you will read the latest articles and see whether the scale has been measured. Just write in the Scholar Google, service quality reflective scale. Read about that particular construct and you will come to know. It is just that you have to read the literature. It is nothing that I will be able to tell you that whether this construct is reflective or formative. You'll have to read the literature, that how people have defined it, how people are studying it. और कई बार ऐसा भी होता है कि एक ही स्केल आपका रिफ्लेक्टिव की तरह भी पढ़ा गया और फॉर्मेटिव की तरह भी पढ़ा गया, right? So that
Yes.
you will have to read and then find out
Yes, ma'am. From the literature itself, I
from
got
the
to know.
literature itself, from the
Or-
literature itself, right?
Yes.
So it will be scale development, not statements development. It will be scale development. Okay. So now what happens is whenever you make a questionnaire, so whenever you make a questionnaire, there are number of items, as I've just discussed. For example, if you have A, B, C leading to D and D leading to E, so we have got 5 constructs here or 5 factors here. And suppose every factor has got 5 statements or 5 items. That means you've got 25 items, right? 5 multiplied by 5, simple. So now what happens is, according to you, you have put this E is having typical E1, E2, E3, E4, and E5. B will have D1 to D5. A will have A1 to E5. B similarly and C similarly, right? But eventually what happens is when you run a factor analysis or when you write the statement of an item of any construct, there is a possibility that the statements are not well written. So suppose if this is an attitude, and this leads to behavior. Now, there is a very thin line of difference between attitude and behavior. So whatever statement you've written as D1, you might find that D1 also, gets overlapped with E1. मतलब वो जब place होती है तो वो यहाँ भी इसमें भी आ जाती है और इसमें भी आ जाती है. Why? Because either that statement is not well written, it is not well understood by the reader, or maybe it has got some different meaning and a reader is understanding in its different form. So we need to avoid such instances. For example, if we have double barrel questions. Now, what are these double barrel questions? What happens? Suppose if I ask you, my boss, I feel satisfied. I feel satisfied when my boss asks me about my family and children. These are two different things, right? So what if a boss asks about the family and does not ask you about the children? Then do you feel satisfied or you don't feel satisfied? Right? There could be a question. I will buy a laptop if it has graphic card and Windows preloaded. Right? So how will somebody answer this question? Suppose if he says that it means that if he gets a graphic card, he will not buy the laptop. So you are putting two conditions here. But there is a possibility that I will also buy a laptop only with graphic cards, or I'll buy a laptop only even if it is pre-Windows loaded, right? So you're giving two options, but I can buy even if one. So this question cannot be answered clearly by a respondent because you're giving him two choices now. Suppose if he's okay with this also and he will buy, then what should he answer? Right? So asking two things in one statement is not advisable. So you should avoid such double barrel questions also. You should always ask just one thing at a time to a reader or to a respondent, right? Okay. Now, factor analysis. Now, what is factor analysis? What happens is, in factor analysis, every item you make under a construct is also known as a factor, right? So don't get confused with factor, construct, and variable. Here, factor analysis considers every item as a factor. So suppose if there are 20 items, that would be considered as 20 factors. Because why do we do EFA? We do EFA to reduce our dimensions. It is a dimension reduction technique. If you even look at the SPSS, it is written dimension reduction. From, if we have 5 constructs with 5 items under each, which makes it 25 items. So logically, what will you think? That whatever items you have assumed in A, B, C, D, and E, all the items will be loaded here under A, B, C, D, and E. However, when you run EFA, there is a possibility that the item which is here loaded under E will get also loaded under D, will also get under A. So there are cross loadings. I'll explain you through the diagram also, right? So what is happening is, so let's just to give you a brief definition, it is designed for the situation where links between observed and latent variables are unknown or uncertain. And CFA is used when researcher has some knowledge of the underlying latent variable construct. मतलब जब आपके पास scale available है, आपने पीछे से adopted scale लिया, then you go for a CFA. This is what it is saying. What is a factor? It is an unobservable variable that influences more than one observed measure and that accounts for the correlation among these. In other words, the observed measures are interrelated because they share a common cause, that is, they're influenced by the some underlying construct. Let's understand this by this diagram. Suppose we've got this model. Now, this playfulness is measured by 4 items. This is measured by 5. This is measured by 5. This is also by 5. And this is by 3. Right? This is your model. When we run EF, now we are putting these items in SPSS. What is the result going to be? What happens to items which were there in the playful? From here, it goes to joy. The item which was there in the efficacy, that also goes to joy. And the item which is here in usefulness, that also goes in efficacy. And you will see similarly under performance, some more items have been added from here and there. So what is happening? Everything gets jumbled up. Now, what is happening actually? Why this has gone here? Whatever the construct or the items you have made here, there is some correlation between A1 and A, right? B also, whatever the factors and the items are there, there is a correlation between B and B1. But there is also a possibility that this B1 also has correlation with this. Now, suppose if this correlation value is less than this correlation value, I'm saying B1 or B. The correlation of B1 and B is less than B1 and A. So this B1 will move from B to A because it is highly correlated with A. So the items which are correlated, highly correlated with any of the variables, that will move to that specific construct. So that is what it is happening in this. Everything gets jumbled. So whatever, if this red dot, why it has gone there? Because it still has a correlation with playfulness, but it has got higher correlation with joy. So therefore, it gets up from here and moves to joy. Similarly, a green star here has got high correlation with performance. That is why it has moved in this area. But it doesn't mean that it does not have a correlation with usefulness. It has a correlation with performance, high correlation. Right? So if you look at this, now how does EFA is defined? It is identifying the underlying theme that is common to factor 1, 2, and 3. is designed for the studies where the links between the observed and the latent variables is not known and is used to identify the structure of data by evaluating correlations between the variables. So this is what we are basically working on, right? So what is EFA? It is a statistical technique that involves the relationship between observed variables and the underlying latent factors, right? And is a technique to construct a questionnaire. So what happens is when this items from red moves to here, so now your questionnaire, when you report your questionnaire after conducting EFA, when you report your questionnaire, now the item which you said was part of a playfulness will not be a part of playfulness anymore. It will go to joy because the item is getting loaded here with high correlation. Are you getting my point or not? Right? So I'll show you also these things. It will move here. So now playful will only have 3 items instead of 4. This instead of 4 items has 5. So this instead of 3 will have 5. Usefulness out of 5, it has now 4. And this also out of 5 now has 4. So the structure is getting changed based on the correlations, right? And that is why we call it as dimension reduction and pilot testing. Why we insist on doing a pilot run before finalizing your questionnaire? Because now your constructs, we have to see whether the items are getting loaded in the place where you want to get them loaded or they're showing some high correlation with other, right? So for an EFA, what is the condition? We have some conditions which needs to be fulfilled. There has to be multicollinearity. What do we call it? For EFA, we need multicollinearity. Then only the EFA will run. And for regression, for higher order techniques, we do not need multicollinearity, right? So what happens eventually? The model earlier was this, right? But when we run the EFA and we see that now the items which were there in playful has moved to somewhere else. Joy wali items have moved to somewhere else. So we ultimately may say that now in spite of, we took 5 constructs, but now we are left with only 4 variables, right? This is what it happens under EFA. What will be the minimum number of statements? Ideally, you should have minimum 3 statements, but PLS also allows you to run the model even if you have 1 statement also. But logically, I normally don't take less than 3 items per scale, right? Okay. So-
Ma'am, once the items got aligned with their dimensions, then after we are going to check the multicollinearity.
मल्टीकोलिनैरिटी क्या होती है? जब आपस में कोरिलेशंस हाई होती हैं. EFA तभी आपका रन करेगा जब आपके उनके आपस में जितने भी आइटम्स हैं, सपोज इफ देयर आर 25 आइटम्स, they should have correlations with each other. They should have correlations with each other. However, when you run EFA, अब आपके पास फिक्स हो गई कि यहाँ पे 5 आइटम्स हैं, यहाँ 5 हैं, यहाँ पे 3 आइटम्स हैं. So what is going to happen eventually? Now there should be no correlation between these two factors which have been identified. However, the items which are getting loaded here, they have high correlation. But this construct A, this construct B, they should not have any correlation between them. If they have correlation, then your structural equation modeling will not have problem. Understood? So when we run EFA, multicollinearity is must. They should have intercorrelations. However, when you, after running EFA, when you go for a CFA and higher this thing, structural equation modeling, the assumption is no multicollinearity. Is that clear?
Yes, ma'am. Yes, ma'am.
Because अब आपके कंस्ट्रक्ट्स अलग अलग बन गए ना. अब भी अगर उनमें कोरिलेशन होगा तो फिर आप कैसे बोलोगे कि डिस्क्रिमिनेंट वैलिडिटी है? व्हाट डू यू डू वंस यू discriminant validity. If I don't know whether you guys are aware of this term, discriminant validity or construct validity or not. Reliability and validity of a
Yes,
construct, right? So how do you, reliability, you do it through cronbach, right? So when your construct is finalized that these items are falling into this construct and these items are falling into this construct, now you have to prove that also. And how do you do that? You do it through CFA, and you prove that this construct is different from this construct. That is given by the construct validity, discriminant validity, right?
yes, ma'am. Ma'am, it means that in EFA, multicollinearity has a मतलब major role to play in, मतलब
In
through which
EFA,
we got to
in
know कि
EFA.
किस item किसके साथ align ज़्यादा हो रहा है.
Correct, correct. So EFA के लिए assumption is multicollinearity, but for other structural equation modeling, जब हम regression run करते हैं, multicollinearity should not be there because we assume that now we have removed that multicollinearity through EFA, right?
Yes,
I
ma'am.
hope this is understood. Okay. Okay, what should be the sample size for the pilot study? Usually we say that it should be 10% of the sample, whatever you're taking. So 50, if it is 500, you should assume 50 is a good size to pilot for pilot run, or maybe 100. So 10% usually it is said that it is a good sample size for pilot study, right? Okay. Now see what happens. I'll explain you once again, those who have not understood. We have got 10 items. Now, when you run these, you assume initially that V1, V2, V3 is a part of construct A. V4, V5, V6 is a part of construct B, and V7 to V10, this is a part of construct C. But when you run EFA, what happens is V1, V5, 7 gets loaded under A. 2, 3, 9 gets loaded under B, and rest of the items, they get loaded under C. So now your factor 1 would be 1, 5, and 7, and not 1, 2, and 3. Understood? This is what I was trying to explain. You have come out with 3 factors, factor 1, factor 2, and factor 3. Okay. Now, so what are the assumptions? It should be done on the interval scale or the ratio scale. Variables must be related. If you have 20 unrelated variables, you will have 20 factors. That's how I explained you in the beginning. Sample should be homogeneous. It should be done on the metric variables. Normality is not required for EFA, right? Correlation among variables must be present. That is, multicollinearity must be present, right? Which is established through Bartlett's test of sphericity. Sample size minimum 50, preferred is 100. So these are the assumptions of EFA. Purpose of doing EFA is to reduce and simplify the data. It is a part of construct validation and a part of questionnaire development and finalization. It assesses the homogeneity of the factors and it obtains the independent factors which are not related to each other, and our data set after running EFA gets ready for CFA. Okay, that is factor analysis. First you go through EFA and then you run the CFA. So under CFA, what do? You do a construct validity and discriminant validity. Right? EFA is a part of your pilot testing. Here, sample size should be greater than 50, preferred 100. Okay. So now, what are the issues in EFA? What we need to discuss? What is the kind of rotation do we need to take? Cross loadings को कैसे handle करना? Negative values को how are we going to handle the negative values? Whether you should go for principal component analysis or whether you should go for PAF, principal access factoring. This is what we are going to talk about in the next thing. So I'm sharing the SPSS screen with you now and to show you how basically we run the EFA. So this is a small data set on some IT products, right? So these are the few statements. 13 statements are there, and we have just taken this age, gender, and income and qualifications. And so this is a data set of approximately 372 respondents, right? So what do we first do? The first thing what we need to check is you go to analyze. Is my screen visible to you? SPSS screen is visible to everybody, right?
Yes, ma'am.
Yes, if your EFA is 400, then my sample will be 40. But try to make it, Pranjali, more than 50 for a pilot testing. Right? You should always take one step ahead, whatever is the minimum thing given. So first step, what you have to do is you go to analyze, you go to descriptive statistics, and you check if there is any missing value. So you go to frequencies and just take all the items. Only the items which are on the interval or the ratio scale needs to be taken, not on the nominal scale, right? So take these and only frequency tables I want. And I'm doing this just to check if there are any missing values or not. Okay, so I go to OK. And this is your pilot step. What I will do is I will just transpose rows and column. Are you able to see the output sheet? So this is the output sheet. Can you see here? So there are no missing values. You can see here that there are no missing values, right? See, missing, there are no missing values. Next is what you have to do is, after that, you need to calculate and check the standard deviation. So what do? You go to analyze. Or what you can do is you can simply take your data to Excel. I'm just copying pasting this data, Control C, and I'm just pasting it in Excel. I'll just share the Excel sheet with you. So I've just pasted this data to an Excel sheet and I'll simply calculate the standard deviation. Now you simply check the standard deviation. Standard deviation should not be close to 0. However, if there are any respondents where you're getting a standard deviation of 0.5, it is acceptable. So you just scroll that it should not be close to 0. Now, what is a standard deviation basically? Standard deviation means what is the kind of variation in your data, right? At times, what happens is variation is important because you need to see that how much variation is there. What happens is at times respondents, they reply in some patterns like 1 1 1 1 1 2 3 1 2 3 1 2 3. So to check such kind of patterns and to see whether there is any variation in the data or not, it is important to check if there is any respondent who has given the was given as the standard deviation or is in the range of 0. There is no variation in the data. So in case if there are such data, then you might have to remove that data, right? So let's go back to SPSS. Are you able to see the screen, SPSS or not? Just let me know, please. No?
Not visible, ma'am.
No, ma'am.
Now?
No, ma'am. Yes,
So
ma'am.
Yeah,
Yes.
visible.
now you go to analyze, and you can see here there's this option dimension reduction, and you go to this factor, right? And we will take all the items here. We take here. Now please understand. I will explain all these things one by one. So you can just first we go to descriptive statistics. Now descriptive statistics always gives you mean, median, and mode. So we're not looking for any descriptive statistics because we're not interested in calculating. That is why I'm not checking this univariate descriptives, right? So initial solution, it is all by default, it is checked here. So what you need to check is we need to check the significance level. We need to check the KMO and Bartlett's test of sphericity, and we need to check the anti-image. So we click on these three and we continue. Next, we go to extraction. Now, there are different methods of extraction. You can see here, there are at least 6 to 7 methods. However, now there are certain rules which we need to understand when we follow any method of extraction. First is the principal component PCA, right, which is called principal component extraction method. And there is another principal axis factoring, which is also known as PAF. PCA, principal component analysis, is used when the factors are not correlated. When the factors are not correlated, right? However, when factors are correlated, then we use the principal axis factoring. So whenever you, suppose if you're from a social science discipline, and we assume that attitude leads to behavior. We know that attitude and behavior are highly correlated, and they, right? So then in that case, we will say that principal axis factoring will be used. But when we know that product quality leads to satisfaction and they are not correlated at all, in the sense that the product quality is absolutely different from satisfaction. So what will we use? We will use principal component analysis. Here, in this case, when we are using principal component analysis, we will take correlation matrix. Now, there are two matrices given. One is the correlation matrix, another is a covariance matrix. So what is this correlation matrix? Correlation matrix, it gives you the strength of the two variables, right? Strength of the two variables. And what is a covariance matrix? It gives you the extent to which variables vary in tandem. Correlation value, it varies from -1 to +1. Covariance value, it ranges from -infinity to +infinity. And we always consider correlation matrix because it does not get affected by items or dimensions or any other thing. So that is why we always consider here correlation matrix. So here by default, we have unrotated factor solution, and we also check on scree plot. Now, there are two things now. Suppose if we are testing a theory. Theory means where we know that this is the Utout model and this is what we're going to check. So when there is a typical theory which we are going to check and we know that the factors are going to be 5 or 6 based on the theory, then we will fix the number of factors which we want to extract. However, when we are not testing a theory and we have brought some changes and we have our own conceptual framework, then we will use the first option, which is based on the eigenvalues greater than 1. Now, what is eigenvalue? Eigenvalue here means that how much that particular factor which has been extracted is contributing, right? How much variation a factor explains. I'll talk about it when you see the results, right? And the maximum iterations for convergence, it is already given 250, we'll make it 250 here, and we will just say continue. Next is the rotation. Now, under rotation, whenever we go for a principal component analysis method, we always choose Verimax. And whenever we run a PAF access factoring, then we choose Promax. So I'll show you the difference when we run Promax and when we run Verimax. Let's first run by Verimax. And we have a rotated solution here. And again, maximum iterations. We can have 250, 350, whatever you want to iterations you want, you can do it. I normally consider 250. Right? And I continue. Then there is this thing scores. When you are sure that now this is going to be my things and you have a fact, you want to have a factor structure, then only you tick this. However, if you're just running and seeing it for the first time just to see that how your items are getting fitted anywhere in the construct, you don't need to check any of the boxes as of now, right? And this last option is options. So here, the missing values, if you have any missing values, you can always tick replace with mean here. However, we have already checked that there are no missing values, so we will not check it. And we will have the coefficient display format. So it is talking about the correlation coefficient between a factor and an item. So sort by size, we are saying, and suppress the small coefficients. So coefficient value, we are saying that keep it anything below 0.3, suppress it. We can keep this value up to 0.5 also. But just to first, as we are running it for the first time, we can keep it 0.3 or 0.4, right? Let me keep it 0.4 as of now, or let me keep it 0.3 only just to show you. And I say continue. So all things set here, and I will simply say, okay. Let me share the output sheet with you. Now, if you look at this, here, this is the first table of EFA, which is known as KMO and Bartlett's test of sphericity. KMO value is 0.871. The threshold is 0.7. So any value of KMO which is greater than 0.7 is acceptable, right? Now, another test is Bartlett's test of sphericity, which is, you can see here that it is also significant. So when you have a significant Bartlett test, that means that it is good to go ahead with the further analysis of EFA. So first thing, you need to check these two values. Now, if you look at this anti-image covariance, now, if you remember, there were two things, covariance, and there was another correlation. And we wanted to check the correlation anti-image, right? So here, if you look at this, what you need to do is you need to check these diagonal values, right? You need to check these diagonal values, which you can see here. It is written 0.900 and there is small a, right? Superscript 0.896, 0.870, 0.877, 824. All the values are above 0.5. And what are these values? These are the measures of simple sampling adequacy. And it should be more than 0.5. So the first thing what you need to check is anti-image correlation, which tells you if the values, you have to check these values, the diagonal, where A is given. If these values are above 0.5, then the sample adequacy is there, right? So then you can move ahead. However, if you find that there is any value which is less than 0.5, you should take a note of it here only. Now, if I go here, can you see here? All the values, 0.927, 0.787, 0.910. I go ahead, 0.805, but there is one value, 0.498. Did you see that? Yeah. Can you see here? 0.498. This value is for Q7. Can you see this value? Please look at my cursor. The value is 0.498. Okay. So if any item has a value which is less than 0.5, so you should take a note that this item may probably cause a problem. So you might have to delete this item, but not as of now. But just take a note of it that Q7 might create some problems. So you move ahead then. The next table which you get is, next is this thing, communalities table, right? So now again, under communalities, look at all the values which are here under extraction column. So what is a communality? Communality, basically, it explains the amount of variance in a variable that can be explained by a factor, right? So amount of variance in a variable that can be explained by this factor. So what kind of variation Q1 explains in the complete factor F1? What kind of variance Q2 explains in the factor F1 if it is a part of F1? So item, what kind of variance an item is explaining in that particular factor. So you again check all the commonality values, and specifically you check for Q7 because we actually have already checked that yes, Q7 caused some problem in an anti-image correlation matrix. Here also it is showing 0.172, right? Can you see here? The value is 0.172, which means there is some problem, right? So we move ahead. So we've got now two indications here that Q7 is creating some problem. So now we move on to the next table, which is total variance explained, this one. Now look here, 13. I told you in the beginning that हमारे जितने भी हम items डालेंगे, उतने factors हमारे extract होंगे. So how many items did we have in the beginning? We had 13 items. And can you see that how many components getting extracted? These components are nothing but the factors. So 13 items we fetched in, and 13 items uh, 13 items are getting extracted as a factor. However, the factors which you need to consider should have an eigenvalue greater than 1. So can you see this is an eigenvalue? This column, these three columns, this is the total eigenvalue. Second column, if you can see my cursor. So anything above 1 should be considered as a factor here. Final factors. So 1.257. So that means 3 factors are there. Out of 13, there are 3 factors which have eigenvalue greater than 1. So how many factors we will say that they are prominent? We will say that 3 factors are getting extracted, and how much variation these factors are causing, right? Can you see here? Total variance explained. This is a table of total variance explained. What is it causing? Look at the cumulative value. What is the variation it is causing? 71.969. First factor is causing a variation of 45.912. This is also a common method bias भी हम यहीं से देखते हैं. 45.912. If it is more than 30, then we say that there is no common method bias. So we can report it from here also. Second factor, cumulative. It is explaining. Individually, it is explaining only 16%, but together 1 plus 2 explains 62% variation. Together, 1 plus 2 plus 3 explains 71.69. Now, what is the basic thing which you need to understand? Now, this is a total variance explained. Now, this total variance explained is made up of two things. One is the common variance and another is the unique variance. Can you see there are two tables? यहाँ पे भी कुछ explain हो रहा है आपका variance के उसमें, और यहाँ पे भी explain हो रहा है. However, you can see the values are different. Right? You can see here the cumulative value is 45.912 and here it is 26.231. So this is a common variance. Common variance means a variance caused by a variable 1 and 2 and 3. मिलकर कितना वो कर रहे हैं, and this is a unique variance. So total variance is basically made up of two variances. One is called the common variance, another is called the unique variance. Okay. Now, next factor, scree plot. You will normally see that the scree plot also is getting reported, was used to, now to nobody reports it. So here also, these are the eigenvalues. You can see here, these are the 3 factors which are getting extracted. So this is the eigenvalue on y-axis, right? And these are the factors, total number of factors. So you can see from this factor, third factor, 2 factor and 1. These are the factors which have value more than 1. So that is why we've got 3 factors. So now under rotated component matrix. Now there are 2 matrices which are coming. One is the component matrix. We don't report the component matrix. We report the rotated component matrix. So we'll look at the rotated component matrix. Now understand 2-3 things from here. What I explained you that हमारे जो correlations हैं, हमारे जो items हैं, that moves from items, they move from one factor to another, right? So now you see here, this factor Q5 is getting loaded here also and getting loaded here also, right? So if here I have suppressed the correlations. If you remember, I had suppressed it and made it less than 0.3 should not be visible. If I make it, don't write anything, so then you will see that all the values are here, which are even lesser than 0.3. So just to make this clear table, I have suppressed those values. So now you can see that the correlation between this particular factor, which is getting extracted here, this Q5 is getting loaded in factor 1 also and in 2 also. However, you will consider it under the factor where it is showing the higher factor loading. And this factor loading is nothing but the correlation, right? So we will say that Q5 is a part of factor 1 and is not a part of factor 2. Similarly, Q9 also is getting loaded here also and here also. Okay, but where is the higher correlation? Here, under factor 1. So this is highly correlated with 1, but is less correlated with 2. So therefore, we will ignore these two values, right? Similarly, if you look here, Q2 is also getting loaded at two places, right? But it is getting loaded here more in this thing factor 2. So we will consider it here and we will not consider it here. Now look here, Q7 is not getting loaded at all. Now we already had two indications above from the NT image and there was communality table. Third indication, it is not getting loaded. So this is the time when you should say that Q7 is not getting loaded and or has got communality less than 0.5, then you can delete your item Q7. Okay. Here also Q13 is getting loaded at two places. Now notice one more thing. Did you see that Q6 has got a negative correlation here, 0.799? So let's check why it has got a negative sign here. Now, what happens is, if you remember that whenever we make a questionnaire, we make it in one form. Now, by one form, I means if you look at the statements, let me just show you the statements once again.
Ma'am, when you're talking about the variances, so variances are from the mean.
Which variances?
Like you have explained in commonalities and the other thing.
Variance क्या होता है मैं आपको बताती हूँ. Give me just 2 minutes. I'll explain. Just आप मुझसे just ask me after 5-10 minutes. Once I finish, I'll tell you what is the variance I'm talking about. Yeah, just give me 5-10 minutes, please. So you look at this value, which is 0.799, right? It is minus 0.799. So let me just show you the variable view. Now, if you look at, this was item Q6, right? Now look here, just read the statements. I like introducing new brands and products to my friends. I like helping people by providing them with information about, people ask me for information, my friends think of me. All these are positive statements. I like to take a chance. Buying a new product that has not yet been proven is usually a waste of time. Isn't it a negative statement? Don't you think it is a negative statement? All are saying, I like introducing new brands. I like helping people. People ask me for information, but it is saying buying a new product is a waste of time and money. So this statement is, all are positive statements, but one statement is negative. So we normally, whenever we make a questionnaire, we try to add 3 or 4 statements negative. Why? Because we want to see that when a respondent is filling the data, he should read the statements carefully. And if, suppose if the answer of this statement is plus or 4, then this statement ka answer bhi 4 hi hona chahiye. But what happens eventually, this is a negative statement. So its answer should be 1 actually, right? Because it is a negative statement. So to check the such kind of false, we add such items. And when we add such negative statements in the questionnaire, these needs to be reverse coded. Reverse coded ka kya matlab hota hai? I'll explain you.
Ma'am,
Yes.
Ma'am, sometimes this statement showing like a positive and negative impact. So in
Hmm.
that case, what we do?
That's what I'm telling you. इस वही बता रही हूँ आपको.
Okay.
Reverse coded. So suppose you have a scale on 1, 2, 3, 4, 5, right? And 6 and 7, or let's say 5 only. So you have from strongly disagree to strongly agree. And you have I like, and there's one statement, I do not like. So when there is a statement which is negative, all our statements are towards one direction, towards liking, but there is one statement which is do not. I like whatever the product you have, right? A of that product, characteristic of that product, C of that product. So here you assume that this person agrees here. But when you say I do not like, so he should actually tick where? Either one or two, na? Isn't it? He should tick here. But what he actually does is, as he's filling, he's not paying any attention, so he might tick here only. So when it ticks here, this means that it is the respondent is not carefully filling the data. So you come to know of a respondent that this data is somehow not good. So what do you do? If the person has filled the data, if suppose the person has filled it correctly and he has marked here or here. So what do? You will say when he has marked 1, you will write it in your Excel as 5. If he has written 2, you will write it as 4. And if he has written 3, you will put it as 3. So this is called a reverse coded statement. Statement needs to be reverse coded. So what do you do basically? You fill the data in this manner in an Excel. So now at times you forget also because when you're filling your data in an Excel, you don't realize that and you don't even remember. So what do? You actually fill the data, but when the results of EFA comes, it shows you that see the value is 0.7. So go and check your statement. So in such cases, what do? We go to transform. I'm sharing the sheet. So what do? So this value, right? Point minus. So you go to transform. This is and you go to compute variable. And here you see new Q6, right? This statement was a Q6 only. So you will write here. This was on a 7-point scale. So one scale higher, 8 minus this one. So you're forming a new variable and you say, okay, right? So when you see this new Q6 has been created, पहले आपका Q6, this was the earlier one, and now your new Q6 is this one. So if you look at the data here, new Q6 has been created, right? So again, you go to analyze, you go to dimension reduction, you go to factor, and you take out Q6 from here and you add new Q6. No further changes done. Only you delete that item from the earlier items which you had put and you add this new one which you have created and you say, okay. So now if you look at the rotated component matrix, the value does not change. The new Q6 value remains the same. However, the negative sign is disappeared. Right? Clear? Any doubts
Ma'am,
so far?
is it necessary to do the reverse coding or can it be interpreted without changing it just by not considering the negative sign?
See, you should do the coding correctly, right?
Yes, that's true. But if it's only the one thing, then
So then you convert it. Check the statement.
so the
Check the
direct
statement.
conversion.
Direct conversion is possible from here. No? I've just shown you.
Yes.
But go and check the statement. If there is also a possibility that the statement is not negative. However, still the negative sign is there. But you go and check the statement at least, whether it is required or not required. Are you getting my point or not? There may be some error also, no?
Yes, yes.
And so that needs to be rectified. So before you just consider that negative sign को हम नहीं consider करते हैं, but you should go back and see what kind of statements you have taken. Right? Okay. So,
Ma'am, can you please just explain how did you reverse code it without in just with the variable from
I just
transforming?
click on the transform, compute variable. And suppose if you have collected the data on 7-point scale, then you will convert it as one scale higher. Suppose if it is on 7-point, you will say 8 minus that statement, Q6. Just take that statement. Suppose it was on, if it is on 5-point scale, then you will say 6 minus and take the statement here. That's it. And okay. Right? Clear? Okay. Now, what should be the next step now? We see here that the Q7 is also not getting loaded. So what will we do? We'll go back, go to dimension reduction, go to factor, and we will remove the Q7 from here also. So that we have a proper factor matrix now. And we go to rotated component matrix and see 0.3 point. We will, can you
Ma'am,
see
we
here?
can't, we can see only your SPSS screen, not the answer screen.
So we go to factor rotated component matrix again, right? So can you see here? The factor matrix structure is getting clear, but we are still seeing these values 0.359 and 0.399, which is a very, very low correlation. So what we are going to do, we'll go to analyze again, dimension reduction, factor, and we will have options. And now instead of 0.3, I will say 0.4 and I continue and I say okay. So when you go to the rotated component matrix, it is absolutely clear now. Can you see? Right? And all the values here are more than 0.5. Ideally, it is good if you have values more than 0.7. However, close to 0.7 are also okay. Any doubts so far? Because iske baad I will be, acha, one more thing left. So you go to analyze now. Now you have finalized your structure, right? Rotated component matrix. Now you go to factors. And now I had left this option scores. Now you go to the scores option and you save them as variables. And as a method which you need to adopt is Anderson-Rubin, and you display factor score coefficient matrix and you continue and you say okay. So now if you check your data set, now you will find, can you see these factors here? 1, 2, 3. The factors which you had extracted. Can you see here? Now these are the factor scores. Correspondent 1, correspondent 2, and all these, right? These are called the factor scores. And whatever the factor scores you have extracted, right, you cannot consider them as it is. Why? Because all the factor scores, they have a mean of 0 and standard deviation of 1, right? So therefore, you cannot actually consider them in the analysis. We really need to have the z-scores for this. So we will do that also. But as of now, we have extracted those 3 factors and we've got these factor scores here for the 3 factors, which I showed you that 3 factors having eigenvalue more than 1 were extracted. Now let's look at the second method, which is known as the PAF. So you remember that? You can see my screen, right? Factor analysis, right? Small window. Now you will have to, descriptives will remain the same and everything will remain the same. Extraction method will also now change because I gave you 2 methods. One was the principal component, another was the PAF method. Now this is based on the common variance between the factors extracted, right? Here, I will now switch to principal access factoring method. Okay. And again, based on eigenvalue, rest of the things will remain same. Rotation. Now, instead of Verimax rotation, I will consider Promax rotation here. Rest of the things will remain same. Scores, I will not consider because I have already calculated the scores because otherwise we will have 3 more scores and I'll cancel. Continue. Options, again sorted by size, press small coefficients. We'll keep it as absolute value below 0.4 and continue and say okay. right? So now again, we have this KMO value. Can you see here? It is 0.873. We have this anti-image matrices as we have earlier also. We have correlation matrix, and now we have this commonalities table as we had earlier.
Ma'am, we cannot see the output sheet.
Show you again. So we have this KMO values, right? And Bartlett's test of sphericity, anti-image matrices, commonality table. I have deleted the Q7, so Q7 is also not here now. And we have new Q6, which was already there. So you can see here the values are more than 0.5, all the commonality values. Now you look here. Now let's understand the difference between what you're getting here in total variance explained and what you got here in PCA method. You see here under total variance explained here, you're only getting this table. Extraction sum of squared loadings. Why you're getting this? Because this is based only on the common variance. However, if you look there, the total variance explained, you can see here that there are two things. Total variance explained is explained by the common variance also and the unique variance also. So there are two things. You can see the cumulative values of two things. However, when you talk about the PAF method, it is based only on the common variance. So here, what is the result? Variation, these factors are showing, it is showing 71.3. And there it was showing 77.54. So which of the two methods is showing the better variation? This method is showing the better variation. But I'm not saying that this is not a good method. I'm showing these are the two different cases whenever we're doing the analysis. Here the factors are not, here in first case, the factors when we assume are not correlated. In the second case, when we do PAF, the factors are correlated, right? So now we move next, scree plot as I've already explained. Now we come to these two things, pattern matrix and structure matrix. These are the, वहां पर हमारे पास क्या था? We had their rotated component matrix, which we consider. Here, what do we consider? We consider pattern matrix, right? This is to be considered. Now you look at the values here, right? So this is to be reported. And you can see here the factor correlation matrix also of factors 1, 2, and 3, which is given here, principal axis factoring. Right? Can you see here how factor 1 and 2 are correlated? What is the correlation value of factor 1 with 2? It is 0.548. What is the correlation value of 1 with 0.3? So now, ideally, you will come to know from here only whether your CFA is going to be good enough or not. What is the condition for confirmatory factor analysis? That आपस में whatever the factors you have extracted, they should not have high correlations, because if they have high correlations, then the CFA will not be validated. So if you look here, your factor 1 is not highly correlated with 0.54. It is correlated, it is more than 0.5. However, it should be less. 0.1 and 3 are absolutely different. Can you see? 1 and 3. Very, very low correlation. So these will not cause any problem. This will also should not cause a problem, 0.548. It should be basically less than 0.5 to avoid any confusion. But just I'm telling you from here only that when you go from EFA to CFA, also you should check the factor correlation matrix. Right? Now, let me show you the means here for those whatever the factors we extracted. Let me just see here Q1, Q2, Q3, Q4. If I look here again, 8, 10, 5, 9. If I go here, transform, compute variable, and I calculate the mu factor. I'm calculating the means now. Mu factor 1. So here the mean will be whatever the, now what items you will put here, you will put these items only. 8, 10, 5, 9. 8, 10, 5, 9, right? So I'll put under factor 1, 8, 9,
It was new Q6.
is new Q6, new Q6, and then is Q5, then is Q9, right? One is this one. So I've created one factor. I'm computing the z-scores from here. So one, I'll create for another now. We'll say new factor 2. And again, I will have mean here. And what are they? Q3, 4, 2. Q3, 4, 2. And Q1. Okay. And I will also have more factor which one? 11, 12, and 13. 11, 12, and we say okay. So now if I show you, can you see here? New factor 1, 2, 3 are here. Right? So in the variable view also, I can show you these are here. So what you can do is, you go to analyze, you go to descriptives, save standardized values. Mean standard deviation. Have the mean value of new factor. Can you see the output sheet?
No, ma'am, we cannot.
Can you see the new factor 1, 2, 3? I have just calculated the mean values, right? 4.8, 4.3, 4.2. Right now, actually what I'm trying to tell you here is that when you are running an EFA, you can have one objective, like, for example, to determine the level of awareness towards technology adoption, for example. So how do you determine the level of adoption? So there are certain factors which you have considered that which maybe could be the reasons for adoption. So which factor is more responsible for adoption? How would you see that? You will see it through means. Suppose if these are the three factors, so what is the mean value here? You will say that factor 1 is more responsible for adoption, followed by 2, and then followed by 3, right? Apart from that, what else you can do is, now you've got these mean values and you've got this new factor scores, because those factor scores which we extracted from the EFA could not be used. However, now we've computed the new variable and we've transformed them. So now we can also we can run an independent sample t-test from here only. So you go and you compare the means, right? On the basis of gender, or on the basis of whatever categories if you have. You can also apply ANOVA, you can also apply t-test. So what you do is, you go take gender, Define groups, say 1 and 2, continue. Right? And what are the 3 factor scores which you are considering? New factor scores for this. So you're saying the mean variance between the male and the female for whatever the awareness, or is the variance, is the level of awareness different for gender or not for all 3 factors or not. So you run that. Okay. So you see, it is not significant. It is only significant for factor 3. Can you see the significant values here? So, right. So you have got this, sorry, यहाँ से देखना, t-test, ये तो Leben's test था, t-test. Can you see here? Significance value, it is not significant. Right? So this is how EFA actually works when you want to look at this. Otherwise, why I did not consider those scores, that also I will show you. Because उन सबका mean and standard deviation, suppose I'm taking these 3 now here, and I say, okay. Can you see here? Mean is 0. Output sheet, can you see the output sheet here? Mean 0 and standard deviation 1. So if the mean is 0 and standard deviation is 1, that means the correlation coefficient is also 0. So therefore, we cannot consider these factor scores. So we need to convert these factor scores first and then use it further for our analysis. Don't use the same factor scores which we have extracted from the EFA. Is that clear? Okay. So let me just take few questions now. Just give me 1 minute, please. Yeah. So I can take your questions related to anything related to the CFA, and then I will tell you those ranking questions, how that can be done. That was left from yesterday's session, so I can just take that. Ask me by unmuting. That will save some time. So there are few I will just see. What is KMO? KMO is nothing but basically it is Kaiser-Meyer-Olkin test, which refers to the statistical measure and it assesses the suitability for EFA. If KMO is more than 0.7, then it gives you a green signal that you can go ahead with your analysis further. Which conversion, Sakshi, do you want me to do it?
Ma'am, KMO, Bartlett's test of sphericity, communalities, these all are requirement for the EFA, right?
KMO is a requirement and Bartlett's test of sphericity is a requirement, but communality is the result.
Yes, ma'am. And ma'am, please explain the variance wala part.
I'll take the Cronbach alpha also after this. I told you that we've got two methods. One is called the PCA, another is called the PA, right? Now this PCA method, it is based on total variance explained, right? If you look at this table, it shows you, it gives you two variances. One variance is called the common variance. So this total variance is actually made up of common variance and unique variance. Now, what is this common and the unique variance? These are the factors, right? And these factors are getting overloaded. So common variance is basically the variance caused by two factors together. So this is common variance caused by two factors. And unique variance is just a variance which is caused by simply any factor. So whenever we run a PCA, it gives you two variances. One is the common variance and the another is the unique variance. So we consider the common variance. However, when we run PAF method, it is only based on the factors are actually, what do you call that, correlated. Here, the factors are correlated. So that is why it is based only on the common variance. Right? आपको वहां पर अगर, if I show you also the results here, total variance explained. See, this is when we went for this thing, this test, PAF. Rotation was PAF. Can you see? It is only showing you total variance explained here, only here, right? But when we chose the method PCA, can you see here? Extraction sum of this one, and then rotation sum of squared loadings. Can you see here? So one is the common variance, another is the unique variance. So we normally consider this cumulative common variance explained here. And in this case, we consider this variance. Right? So that is how it is. Yes, both KMO and Bartlett test should satisfy for EFA. Yes, both. Bartlett's test basically tells you that the correlation matrix has significant correlation between the variables. So basically a condition of multicollinearity, which is important. So that is a Bartlett's test of sphericity tells you that there is a sufficient correlation between the variables, which is important, right? It is, EFA is based on that assumption only. That is why.
Ma'am, so the variance is not like a mathematical variance that we have read. It's just theoretical variances between the
No,
as you
you
have
are talking of standard deviation and variation.
yes.
Are you talking of that? No, no, that is different. स्टैंडर्ड
Yeah.
डिविएशन तो मैंने आपको बताया था ना, स्टैंडर्ड डिविएशन इज डिफरेंट. जब हमने शुरू में टेबल को किया था तो कैसे हमारा वेरिएंस उसमें आता है. अब ये वेरिएंस फैक्टर्स एक्सट्रैक्ट होके एक्सप्लेन करें, वो वेरिएंस जो हमने बात किया था वो रिस्पोंडेंट का वेरिएशन था. यहाँ पे जो फैक्टर्स एक्सट्रैक्ट हुए उनका कैसे वेरिएशन है, हम उसकी बात कर रहे हैं.
Yes, ma'am. Yes.
There's a difference between the two. Anything else? Okay. All right. So let's proceed further. Let me take you to some other questions which we left yesterday. Now, this is one example which I wanted to show you. Now, rank the importance of items for your vacation and rank most important as rank 1. So there are few items which are given that on the basis of which you will actually make your vacation. Cost of traveling, weather, cost of hotel, distance, locations, or sightseeing, right? So what do you do is, suppose now so we have number of options given to a respondent.
Ma'am, we can see only the output sheet.
I'm sharing the same. Let me share it again. Now, can you see?
Yes. Yeah.
Now, suppose there is a question. Rank the importance of items for your vacation, and you're asking a respondent that these are the particular items, how do you rank them? So these could be product also, or these could be your anything related to your research. Okay, for example, these are, and this is a very general question which we ask in the marketing. Suppose if you're using ChatGPT or if you're using any AI tool, so you may ask that rank the tools, right? So that could have been the question for you. Suppose now we are choosing between these. So how are you basically going to do? For example, here you have vacation. You've asked the questions. Your first choice was traveling, weather, cost of hotel. So you have traveling, cost of hotel, weather, right? Now you look here. The respondent, how, and you're answering it on a scale of 1, 2, 3. Sorry, you're ranking, right? Ranker now. So you've ranked it as, these are the respondents, 1, 2, 3, 4, 5, 6 respondents. Here, you've given this rank as 1, 2, 3, and 4, right? This respondent has given this as 4, 2, 3, 1. This has given as 2, 1, 3, 4. This has given 5, 1, 2, 3, 4. 4, 3, 1, 2. So 1, 4, 2, right? So how many person have given vacation as rank 1? So you will calculate that. How many people have given vacation as rank 1? So how many have given 1, 2, 3? So let's see one more also. So 4. So how many people have given traveling as choice 2? So you will again calculate that. 2, 3, whatever number you get. So once you have that number, you just fill that number here, right? So once you do that, you have to give the weightage. Anybody who has given rank 1 to a particular thing, you will give this number a weightage of 5. Rank 2, 4. Rank 3, 3. Rank 4, 2. Rank 5, 1. So people who have given, so respondent 1 has given 4 this. Rank उसने क्या दिया यहाँ 4, 2, 3, 1. Right? कितने यहाँ पे कितनों ने दिया 6, 3, 4, 6, whatever. So here respondent 1 cost of traveling. अब इसको किससे multiply करोगे 2 से. यहाँ पे respondent 2. What is it? 4. So you'll multiply it by 4. 9. किससे करोगे? Third rank into 3. So 2 multiplied by 1. And you add all this. This will be multiplied by 5. So 5, 4, 3, 2, 1. And you plus. Similarly here, weightage 1, 4, 3, 2, 1. Here again, 5, 4, 3, 2, and 1. 58. Similarly, 5 weightage, 4, 3, 2, 1, and 17. Similarly, 5, 4, 3, 2, and 1. So whatever the point is higher, here the highest is what? 84. So people have ranked cost of traveling as the highest factor for choosing your destination, followed by distance, followed by cost of hotel, weather, and then the least is number of locations for sightseeing. This is how you do it. Options can be ordered, how much pain, size of a dress, product, or whatever you're choosing. On the basis of that, these questions should be answered in such a, right? Now, let me take you to this thing again. To calculate, show you how to calculate the reliability. Now you have got these factors extracted. So let's talk about the rotated component matrix from here. You've got 8, 10, 6, 5, and 9. So how will you do? Analyze, and you go to scale, and you will go to reliability analysis, because now you have to calculate the reliability, because now the factors have been adjusted again based on the new items. So we will take Q8, Q10, Q5, Q9, Q3, and sorry, not Q3. Just Q9. one is left? 8, 10. And statistics. So item, scale, Cronbach alpha. Here it is written. And so what is the Cronbach alpha of that construct? 0.87. And how much it should be? It should be more than 0.7. Cronbach alpha should not be more than 9.5. If it is there, then also there is a problem. So it should be close to 0.8, 0.9. Now, item statistics is given. And now you look at this item total statistics. How do you read this table actually? See, what is the Cronbach alpha value? It is 0.877. And here, if you look at this, that is the highest. Suppose if that would have been lowest, suppose if it was 0.8, let's say 0.804. So how would you read this table? You would say, it is saying that if you delete this item 8, then Cronbach alpha will become 0.824. If you delete this item, it will become 0.834. If you delete this, it will be 0.864. In case if this is less, then only you have to look at this. In case if the value is more than all these Cronbach alpha, if item deleted, then you don't have to consider it. But at least check this, right? And these are the scale statistics given. 24 is the mean. Variance is given, standard deviation, and number of items. So what you need to report is Cronbach alpha, the reliability, which is more than 0.7. So your scale, your construct is reliable. Similarly, you will have the factor 2. You check the reliability for factor 2 in the similar manner. You go to scale, reliability analysis. Earlier you checked for this. Now you can check for the other, whatever it was. I'm just randomly checking for you. I don't know whether it will become reliable or not, but I did not take the exact value, so it is coming wrong here. But you've understood the point, right? So I think that is it from my side. Now you can ask me any question, whatever it is. Is reliability done after EFA? Yes, it is done after EFA. People usually do it before running the EFA also. But ideally, you should always check the reliability after running, because EFA, reason being because now you get your scales right. You get your items adjusted in one or the other factors, and now you've got these factor scores and everything. So that is, if your items have not moved from any place, and if your items are where they were actually placed by you, then it doesn't matter. But if yes, the items have moved from one factor to another, definitely you should check it, right?
And ma'am, validity after CFA.
Yeah, CFA is a different concept altogether. So we have to run the confirmatory factor analysis, which is run in either the AMOS or PLS.
Yes, ma'am. And
And
ma'am,
AMOS,
क्वेश्चनियर की भी रिलायबिलिटी एंड वैलिडिटी चेक करनी होती है इन सम
यही
केस
तो किया आपने अभी। ये जो रिलायबिलिटी है, ये आपने जब कंस्ट्रक्ट की चेक की तो क्या चेक हुआ? कंस्ट्रक्ट की रिलायबिलिटी ना चेक हुई आपकी।
यस
और
मैम
कंस्ट्रक्ट कहाँ पर है आपका? क्वेश्चनियर में ना।
ओके
तो हम बोलते हैं ना, जब क्वेश्चनियर की रिलायबिलिटी चेक की तो दैट मीन्स दैट आपने जो आपका फैक्टर है उसकी रिलायबिलिटी चेक की कि नहीं।
यस मैम एंड देन आफ्टर ईएफए फिर हमको दोबारा से रिलायबिलिटी चेक करनी होगी
लॉजिकली यस, बट अगर आपके
ओके
कोई चेंजेस ही नहीं हुए हैं देन इट इज डिफरेंट, बट यू शुड
यस
ऑलवेज चेक।
यस
Ma'am,
यस,
good evening, ma'am.
गुड
Prabhakar
इवनिंग।
here. I have developed a questionnaire by taking items of a construct. I know the variables already. Items of the constructs from the chart GPT. And for some items, I have checked LR, then floated for data collection, got 202 responses. I checked,
202.
Hanji, the 200, this Cronba, for validity for each construct, Cronba is good, and regression is good, and all other items are good.
Hmm.
But then when I'm running the structural equation model,
Hmm.
the main two variables, that is brand loyalty and CSR perception, corporate social responsibility perception, they are not matching in the model. I have a model, everything. Now, I couldn't run the EFA because I didn't know what to do, but trial and error many times, many ways we have tried, but there are issues in the validity. Now, should I make a new questionnaire again by going through LR in the way that you have said today? Or is there any way I can troubleshoot? I have also reduced dimensions. I have reduced questions, some questions
Sir,
to
ideally
improve the value.
speaking, ChatGPT is not the right way to construct a questionnaire, number one.
Hmm.
Number two, if I assume that maybe your questionnaire is correct, as you said that you have referred the LR and then you have floated it by
Yes, ma'am.
cross-checking things.
Cronva, I have checked
Yeah.
Cronva at each stage, pilot study, 100, after 100
No,
response.
I'm talking of the items here.
हाँ
So,
जी.
if you have checked it from the literature, if I assume that also, so now there is a possibility that there is a biasness in the items or by the respondents. The data is not good probably. Or the other option is that you can collect some more data. You have
Oh,
just collected a sample of 200, right?
yes, ma'am.
And you are doing it on MOS or PLS?
I was doing it on Amos
For
and also
MOS, the data size should be more than 250 minimum, ideally. So I will suggest you collect at least 100, 200 data more and then rerun it.
okay. I don't
That
have
is
to
how.
discard this data and start afresh again. No, no, all over again. Not.
I don't think so. That is going to increase your work. But
Hmm.
ChatGPT was not a good option at all to check the
Got it. Got it.
items. That was the
Yesterday
first
also you
mistake
were
you
saying.
did. You did
And
actually.
so
So
if I again go through LR the way you have said today, adapted and adapted statements take and try to do it and reframe the questions. But
maybe you can.
keeping the same data, 200 respondents, and run it for another 100, would that help?
Yes, sir. I think you should do that. Rather, you develop or improve the questionnaire by now going to the literature back and make a new questionnaire and collect the data on this new questionnaire and then check. So maybe.
Then I can what do you call this? Match these two later.
Yes. Then you
Data.
can merge and
You
see
use
whether the
this
result
to.
is getting improved or not. So
Oh
you
yeah.
should actually rectify your questionnaire first.
I do that. Then I get another pilot study
Yes.
with the EFA, and then afterwards, these 200 responses that I got, can I merge them with this?
So you can try merging them. Maybe you get the good results because now the next 100 is going to be better than these 200.
Hanji. So as per this 100, I can always use this to merge, no?
Yeah, you can use, but let's see. I mean, I can't comment on that because I don't know what kind of data is that. So maybe first you try on 100, or maybe you can
uh,
collect 100, 150, and then see from 200 whether you are able to take some or not. Because for a MOS, 250 is an ideal sample size, not less than 250. So increase
oh,
the sample size.
Hanji. Okay.
Right? Yeah.
Thank you.
Good evening, ma'am.
Good
Good
evening.
evening, ma'am.
Yeah.
Just want to ask one question. See, in the questionnaire, how many questions should be there? I mean, is there any benchmark for that? Uh, because more we add the items, then I think it will be difficult for the respondent to answer all those questions.
So, ma'am, ideally it should not be more than 60, 65, I think, because then it
Okay.
becomes, they don't read and then it becomes difficult for you also to manage. So ideally try to make it somewhere between 55 to 60.
Okay. And one more thing, that all the scales should be included in the questionnaire.
All the scales, I didn't get your question.
That is your ordinary scale, and then
No, that
interval
depends on
scale?
an objective. No? That depends. That is what we need to understand, that what kind of questions you need to frame for your question, for your objectives. If your
Okay.
objective is something like to check the level of awareness of the respondent, or to see what kind of technology or what kind of OTT platform they're watching the most, then you don't need an interval scale. Na? Then what would you do? You will calculate on the frequencies, right?
Frequency. Yes.
है ना? अगर आप तो आपके ऑब्जेक्टिव पे डिपेंड करेगा कि व्हाट टाइप ऑफ स्केल यू आर यूजिंग. अगर आपने
Okay.
डिस्टेंस मेजर करना है तो यू कैन नॉट मेक इट ऑन ग्राम्स ना, सिंपल
Correct.
है ना. तो दैट यू नीड टू सी कि अगर आपको अवेयरनेस निकालना है तो आपको मीन वैल्यू, और मीन वैल्यू तो आपके ऑर्डिनल से इंटरवल में आ जाएगी, तो आपको रेशो पे जाने की जरूरत नहीं है. करेक्ट.
Hmm.
और अगर आपको
Hmm.
रैंकिंग निकालनी है तो आपको ऑर्डिनल स्केल से आ जाएगा.
Correct.
फ्रीक्वेंसीज निकालनी है तो भी आपका ऑर्डिनल और नॉमिनल से आ जाएगा. तो और अगर आपको कुछ मॉडल टेस्टिंग करनी है तो आपको रेशियो स्केल में या इंटरवल पे यूज करना पड़ेगा. सो दैट इज फॉर दैट. आप अपने ऑब्जेक्टिव को माइंड में रखिए व्हेन एवर यू आर फ्रेमिंग द क्वेश्चंस. दैट इज व्हाट यू नीड टू अंडरस्टैंड.
Okay.
राइट.
Yeah. Yeah. And is it pre-decided that what I am supposed to, apply the test, and according to that I have to frame my questionnaire?
सी यस, सपोज इफ यू आर मेकिंग, जैसे आपने बोला कि मुझे चेक करना है कि इफ देयर इज एनी डिफरेंस इन जेंडर टुवर्ड्स यूसेज ऑफ एआई, लेट्स से. ठीक है. तो अब इसमें मेरे पास क्या आ गया, यूसेज ऑफ एआई, और दूसरी तरफ क्या आया, जेंडर. अब
Gender.
मुझे वेरिएशन चेक करना है, तो वेरिएशन चेक करने के लिए मुझे टी टेस्ट लगाना पड़ेगा. सो
Okay.
फर्स्ट यू शुड अंडरस्टैंड कि कैसा ऑब्जेक्टिव होगा और कैसा टेस्ट लगेगा. इसके लिए अब आपको, अभी आपने क्वेश्चन डेवलपमेंट सीखा है, अभी आप इसके साथ पैरेलली यू शुड ऑल्सो लर्न हाइपोथेसिस टेस्टिंग. On what basis? I'll tell you few basic things. Suppose if your independent variable is categorical. Now you understand the term categorical, right? Categorical मतलब जहाँ दो categories हैं, gender में दो categories हैं, male female, है ना. Age में हमने young and old ले लिया. If your independent variable is on two categories and your dependent variable is on 5-point scale, then t-test will be applicable. If there are more categories, more than two, let's say education, you have 10th, 12th graduation. So, and your dependent variable is on 5-point scale, interval scale. Then what would you take? Then you will take a ANOVA. If you're testing a theory or a model, then it would be regression. That if you say that what is the impact of A on B, so what it would be regression. So
Sure.
there are few basic tests which you need to understand. For example, when do you need to apply univariate? When do you need to apply bivariate? When do you need to apply multivariate? So just understand these techniques. Basic. I'm not saying go very deep into all these things, but at least the basics of this should be very clear. तभी आप अपना ऑब्जेक्टिव रिसर्च क्वेश्चंस को और क्वेश्चनियर को एक साथ अलाइन कर पाओगे. राइट.
Okay. Okay. Thank you, ma'am.
Yes. Any other questions? No, you cannot check the reliability without having the responses. So you need to have the responses first to check the reliability and validity. Data kahan se aayega un responses? Validity, yes, you can check the content validity of the questionnaire. You can talk to few experts and see whether those items with whatever you have prepared, are they talking of the same construct what you have talked about? So you can check the content validity or the face validity.
Okay,
Right?
ma'am. And reliability only after the case
Yeah,
of
yeah.
virtual response.
जब तक आपके responses नहीं आएंगे तो आप कैसे, डेटा होगा तो आप कुछ करोगे ना आगे. Right?
Yes.
Yes. Yes, Pranjali. When
Ma'am,
you realign the factors, जब आपके नए factors आते हैं, then you see what items are there in each factor now. So maybe you have to rename the factors as per the items which are getting loaded in that. Right?
Ma'am, for our thesis, If suppose we have published some article and we have considered some constructs and items, so can we include them in our thesis if other authors have not considered them? And if our paper has been published in a good journal?
Come again. I didn't. Your question is not clear to me. Come again.
I'm working on my thesis and I have published certain articles,
Okay.
certain papers, and some of the constructs or items are included newly by me, and those are not being considered by other authors. So, can I take a reference of those new added items and constructs in my thesis?
Yes, you can. You can. But
There's no
yes,
problem.
you can. Yeah, you can.
Okay.
But it might come under self-plagiarism. So tweak those in case if you want. Questionnaire normally at times what happens is there is a case of self-plagiarism also, but normally we don't put the questionnaire and turn it in. So we don't do that. But however, when you write your RM chapter, you describe your measures taken, right? So in that case, it might come under self-plagiarism. But then you might change few things in that. You might tweak them a bit and write.
Ma'am, when we form questions on our own, then what one need to be taken care of while framing the question on their own? Like it should be again backed by the literature itself.
It should be. Yes, it should be.
Or
Don't
ma'am, there's
make
a
the whole construct on the basis of your own survey or whatever, if you're referring to literature. Suppose if you're getting 5 items from the literature, you can add 1 or 2 from yours, this thing, but not many.
okay. Ma'am, with the help of interview and all that.
Yeah, you can do that. You can do that. Validity testing for the questionnaire could be through face validity or the content validity you can do.
Okay, if all the questions are done, shall we go ahead with the vote of things? Shall I go ahead?
Yeah, please. Yeah.
On behalf of the organizing committee of Sridhara Kakula College, I would like to extend our heartfelt gratitude to each and every one of you for making this e-workshop a success. We are deeply thankful to our esteemed resource person, Dr. Shalini Sahani, for sharing her invaluable insights and expertise with us. Your contributions have indeed enriched our knowledge and understanding, ma'am. It was really a wonderful experience. We also appreciate the active participation and engaging discussions from our attendees. Your enthusiasm and feedbacks are invaluable to us. Lastly, a big thank you to the entire team who worked tirelessly behind the scenes to ensure the smooth execution of this e-workshop. Thank you once again, and we look forward to your continued support in our future endeavors. Thank you.
Thank you, Poonam.
Thank you, ma'am. Thanks a
Thank you,
lot.
everyone. Thank you.